Hi everyone. In this lesson, we're going to learn how to combine like terms and how to solve equations where you have to combine like terms. Let's begin by defining what a like term is. Like terms share a common variable with a common power. Let's look at our first example. So we have the sum of 4x plus 2x plus 6x. All three of these terms have a common variable x, so we can add them together. And it's not just x, it's actually x to the first power. When we don't write out the power, it's automatically understood to be 1. So they all share x to the first power. So we can combine them. 4x plus 2x is 6x, plus 6x is 12x. So this can simplify to 12x. Okay, let's keep going. So we have 3y here and 7y here. We can put the y's together because they are like terms, giving us 10y. And then we can put the numbers plus 4 plus 9 together to give us plus 13. Because they are numbers without variables, they are said to be like terms. All right, let's keep going. 3k plus 10k, these are like terms, so we can put them together to give us 13k, and then we'll just add the 7. We cannot combine the 7 to the 13k because the 7 does not have a k. It does not have a common variable. All right, let's look at the next one. We can put negative 4w, I'll circle it. We can take this and put it together, combine them to get negative 12w. And then we'll just add 6. We can't put 6 together with negative 12w because 6 does not have a w. All right, let's keep going. So I have an x term here, negative 2x and negative 10x. These are like terms. I can put them together. This will give me negative 12x. And then I'll just subtract 24. And that's it. So this simplifies to negative 12x minus 24. All right. These two have a common variable with a common power, x squared, x squared. So we can put those together. That'll give us negative 2x squared. And we can put these together because they have the same common variable x to the same common power, 1. If it's not written out, it's automatically understood to be 1. So 4x plus 5x will give us 9x. So this expression simplifies to negative 2x squared plus 9x. Let's keep going. So now we're solving equations, and these equations include the added step of having to combine like terms. All right, so let's get started. You have 3x here and 5x here. You can put those together to get 8x. And then copy the rest of the equation. And then solve it like you've solved equations before. So subtract 2 from both sides. We'll have 8x equals 10. Divide both sides by 8. And x, 8 goes into 8. 8 goes into 10, I'm sorry, 1 time. And we take 8 from the top, you're still left with 2 8s, but this can be reduced to x equals 1 and 1/4. All right, let's go to the next one. So you have negative 4x minus 3x. These are like terms that we can put together to give us negative 7x. Copy the rest of the equation. Add 6x to both sides. Negative 7x equals 27. Divide both sides by negative 7. Okay, so 7, just think about 7. How many times does it go into 27? 3 times, because 3 times 7 is 21. and we take 21 from the top, we're still left with, 6. 6 over 7. But because our fraction is negative, our answer should be negative. Our mixed number should be negative. All right, let's keep going. So here we have decimals. So these two terms are like terms. We can combine them, giving us 0.9x equals 2.7. Divide both sides by 0.9. X equals 3. Okay, so we have like terms here. We can put those together, giving us negative 0.4m equals 8.4 divided by negative 0.4. This will give us m equals negative 21. Okay, let's keep going. All right, so now here we have fractions with like terms. We would like to get rid of those fractions to make solving this equation easy. We're going to need to use the least common multiple. So think about it this way. Let's try that again. What number could you put in the numerator that 2 will divide evenly and 3 will divide evenly? If you said 6, that is correct. So that's the least common multiple. So we're going to multiply through by 6. Every term by 6. This will help us get rid of all the fractions. Okay, so now you have 6 times 1 is 6 divided by 2. That's 3x. Plus 6 times 1 is 6 divided by 3. That's 2x. And negative 4 times 6 is negative 24. 3x plus 2x, we can combine those because these are like terms. So that's 5x equals negative 24. Divide both sides by 5 to get x by itself. 5 goes into 24 4 times, because 4 times 5 is 20. When you take 20 from the top, you're still left with 4. 4 over 5. Because your fraction is negative, your mixed number should be negative. Because we don't want to change the value, we just want to change the form. And that's it. Let's go to the next one. Let's get rid of the fractions. We need to come up with the least common multiple. If you said 12, that is correct. Multiply this by 12, multiply this by 12, and multiply this term by 12. Every term. 12 times 1 is 12, divided by 3 is 4x. 3 times 12 is 36, divided by 4 is 9x, equals 24. Well, that's 13x equals 24. Divide both sides by 13, and x equals, well, 13 goes into 24 one time. We take 13 from 24, you're still left with 11 over 13. Okay, let's keep going. Let's come up with the least common multiple to get rid of the fractions. And if you said 20, that is correct. Multiply every term by 20. Okay, 20 times 4 is 80, divided by 5, that's 16x. 20 times 1 is 20, divided by 4 is 5x, equals 20. 16x minus 5x is 11x, equals 20. Divide both sides by 11. Okay, 11 goes into 20 one time. We take 11 from 20. We're still left with 9 over 11. Okay, let's look at number 8. Our least common multiple is the same, 20 again. So we want to multiply this by 20, multiply this by 20, and this by 20. Okay, so this will give us negative 5d, because negative 20 times 1 is negative 20, divided by 4 is negative 5d. And negative 2 times 20 is 40, divided by 5 is 8d. And 39 times 20 is 780. All right, negative 5d minus 8d, that's negative 13d, equals 780. Divide both sides by negative 13. And this is DSN, so it's going to be negative. And that'll give us negative 60. Okay, let's look at number 9. So some of you might be confused because this is x. Okay, you might wonder, well, what number is that? Well, just put a 1 in front of it. It's just 1x. So now you can add 1 plus 0.015. That'll give you 1.15x. Because they are like terms, you can combine them. Divide both sides by 1.15, x equals 3. Okay, we have like terms here, so we can put those together. So this is going to be 9.7, negative 9.7x equals 223.1. Divide both sides by negative 0.7. So this is DSN, different sign negative, and we're going to get negative 23. Okay, this brings us to word problems. A city population of 350,000 has decreased by 30% in the past 10 years. What was the population of the city 10 years ago? Okay, this is now. This is the population now. Okay, 10 years ago, we don't know what the population is. So we can just say P for population, whatever that amount is. Okay, and since it has decreased by 30%, you want to turn your 30% into a decimal. So you're going to have to divide by 100. So that'll give you 0.3. So you're going to subtract from your total population, you're going to subtract 30% out of that, which is 0.3 p. Okay, you need the variable p because you're subtracting 30% of p itself, the population. And that brings you to the present amount, which is 350,000. So now you have written this equation, you can solve this. This is just 1p. So 1p minus 0.3p, that's 0.7p, equals 350,000. Now divide both sides by 0.7 so you can find p. So p equals is 500,000. So it was 500,000 10 years ago. Okay, let's do the next one. A city has a current population of 200,000. This is 200,000. The population has increased by 22% in the last 5 years. What was the population 5 years ago? Okay, so right now it's 200,000. But it wasn't 200,000 5 years ago. We don't know exactly how much it was, so we'll say it was P amount. P for population. And this population increased by 22%. So you're going to take 22, divide that by 100, and turn it into a decimal. So 0. So that population increased by 0.22 of itself, P. And which brings us to the current population, 200,000. So what was the original population? Well, this is 1.22p. Put your like terms together. Divide both sides by 1.22. And you'll get p by itself. And we'll just divide. So this gives us 163,934 approximately. So it gives us approximately this population. All right, let's keep going. Celine bought a computer screen on sale 35% off the original price. What was the cost of the computer screen before the sale if the sale price is $15? So she only paid $15 after a 35% discount. So we need to find the original amount, the original price. So let's say the original price is just P. We don't know exactly what amount. And they took off 35%, turn that into a decimal, and that'll give us 0.35. So we're going to take 0.35 off the original price P. And that brings us to the sale price, $15. Okay, we just have to solve this. This is just 1p. So this will be 0.65p equals 15. Divide both sides by 0.65. And p equals, let's see what that is, 15 divided by 0.65. So it was $23.08. Okay, let's see. Celine bought a calculator on sale, 30% off the original price. What was the original cost if the sale price was $49? Well, this one is just like the other one. Okay, so we don't know what the original price is. We'll say P. Since they took off 30%, change that to a decimal. That's 0.3. So we're going to subtract 0.3, okay, which represent 30% off the price, P. This will bring us to the price she paid, $49. Okay, that's 1. So 1p minus 0.3p, that's 0.7p equals 49. Divide both sides by 0.7, and we'll get our answer. So the original price was $70. Okay, let's keep going. John bought a phone 25% off the original price. What was the original cost if the sale price was $270? Again, it's the same thing. We want the original price. Since we don't know the original price, we'll just say P. They took off 25%, change that to a decimal, and that'll give you 0.25 off the price, P, which brings you to the sale price, 270. That's 1p, so 1p minus 0.25p, that's 0.75p, equals 270. Divide that by 0.75 to get p by itself, and the price will be 270 divided by 0.75 is $360, is the original price. Okay, last one. Henry's found a recipe that calls for 2 2/3 cups of flour for the batter and 1/2 cup of flour for the topping. He has 95 cups of flour. How many cakes can he make? Okay, so every cake that he's going to make, he's going to need this much plus this much. To make that one cake, he's going to need this much for the topping and this much flour for the batter. So we need to add those together, 2 2/5 cups plus 1/2 cups for each one cake. But he has 95 cups. How many cakes can he make? So let's put 95 here because he has 95 cups. Once we know how much each one cake will use up, then we can divide it by 95 to get how many cakes we can make out of 95 cups. All right, let's just turn this into an improper fraction. So that's 12 over 5c plus 1/2 c equals 95. Let's multiply through by 10, least common multiple. So this will give us 24c plus 10 times 1 is 10 divided by 2 is 5c, and this will be 950. Okay, so this gives us 24c plus 5c is 29c equals 950. Divide 950 divided by 29, and we'll get at least 32 cakes. At least approximately 32 cakes. And this concludes this video on solving equations with combining like terms.